So we have a orientable surface that you see right out here. We have our parameterization of that surface, and we want to get a formula for ds. We already have the magnitude of the area of a small surface area element, okay? That's here, okay? This is the, if you'll recall, this was derived for the for ds, okay? Now how do we get n hat? Well, partial r partial u cross partial r partial v, well, that's normal, okay? This is normal to surface, okay? So you're taking two tangent vectors and crossing them together. You'll recall that these tangent vectors are running along the surface, cross them together, and you end up getting a vector that's normal. Now that vector might not be a unit normal, okay? So we divide by the magnitude of it, okay, to normalize, to make it magnitude 1, this normal vector. And doing so, you could then cross out the magnitude in the denominator and in the numerator, coming from different things, and you end up with this expression for ds. And we could put all of that together and write a formula for the surface integral of vector functions, or we could call them flux integrals. Flux integrals, surface integrals of vector fields. Okay, if you hear flux integrals, generally that's what they're talking about. We did look at line integrals, but now this is the we looked at flux integrals of lines. Okay, we call them vector flux line integrals, and here more generally you're doing it over a two-dimensional surface. So once you go to R3 space, a flux occurs over a surface, not a line. Only in R2, the plane, did a flux occur across a line. Now we're talking about flux in R3, and we're doing it through a surface. Okay, and here's the formula for it. You plug in your parameterization into your vector field, and writing this whole expression out, you know, it takes quite a bit of room. And you dot it with this vector here. You have du dv, and you have the bounds from the parameterization. This integral is taken over r, which is in the uv plane, and s is the surface there. And so now you have the formula for a vector, a surface integral of a vector field.